Hi everyone and welcome to this tutorial on polynomials. Okay, the question goes thus. Given that x squared minus 1 is a factor of f of x, where f of x equals ax cubed plus bx squared minus x plus 2, where a and b are real constants. We are asked to find the values of a and b, and then we are asked to solve the equation f of x equals 0. All right. To be able to answer this question, we need to master two theorems under polynomials. The remainder theorem, all right, all right. The remainder when the polynomial f of x is divided by x minus a, that remainder r is given as f of a, okay? So what have we done? We first of all set x minus a equals to 0, and we'll have x equals to a. And then we'll come and put that value of x in the polynomial expression. We're going to get the remainder. So that's the first theorem. Then the second theorem is actually an offspring from the remainder theorem, or it's just a sister to the remainder theorem. A particular case of the remainder theorem is called the factor theorem. It's called the factor theorem. All right. Now, if x minus a is a factor of the polynomial f of x, what do we expect the remainder to be? We expect the remainder to be 0. So when we take the polynomial f of x and divide by its factor, just like with numbers, if we divide a number by any of its factors, we expect the remainder to be 0. And so this remainder from up there, we expect therefore that f of a should be 0. So these two theorems, and most especially the second one, the factor theorem, is what we are going to need to be able to solve this polynomial question. Okay. All right. So after revising this theorem, now let us get into the question. Let us get into the question. So our polynomial expression f of x is ax cubed plus bx squared minus x plus 2. And we are told that x squared minus 1 is a factor. Okay, now let's look at x squared minus 1 carefully. It is a quadratic because the degree is 2. So we expect two factors here already. And if we look at this, we can write this as the difference of squares. X squared minus 1 can be written as x squared minus 1 squared. And so when we bring in the difference of squares identity, we're going to have x minus 1, x plus 1. So already we know two factors of that polynomial. If their product is a factor, then each of them individually or separately are also factors. This is a factor, that is a factor, the product is also a factor. Just like 6, all right? 2 is a factor of 6, 3 is a factor of 6. Their product definitely is going to be a factor of 6. All right, so already by implication, we know two factors already of the polynomial f of x is equal to ax cubed plus bx squared minus x plus 2. So we're going to work with each of those factors now in turn. All right, taking x minus 1, we'll set it equal to 0. This will mean that x is equal to 1 is a root. So we expect the remainder of that root to be 0, since x minus 1 is a factor. All right, let us put it in the expression for f of x. So f of 1 now, therefore, f of 1 we expect it to be 0. So f of 1, that means wherever we find x, we put 1. So we're going to have a into 1 cubed plus b into 1 squared minus 1 plus 2. All right, we expect this to be equal to 0. Okay, So let us put a column here, f of 1. All right, 1 cube is 1, multiplied to a is a. 1 squared is 1, multiplied to b is b. And then minus 1 plus 2, we expect that to be 0. All right, if we leave a plus b on the left hand side and carry the constant on the right hand side, then we're going to have a plus b is equal to this negative 1, carrying that way become positive 1. This is positive 2, carrying that way becomes negative 2. That will give us a plus b is equal to negative 1. All right, we can put that in a box. Okay, we'll call it equation 1. Now, if we have considered the first factor, x minus 1. Let us consider the second factor, x plus 1. All right, if x plus 1 is a factor, then let us set x plus 1 equal to 0. That means x is equal to negative 1. Negative 1 is a root, and so we expect f of negative 1 to be 0 since x plus 1 is a factor. All right, so let's put negative 1 in our expression for f of x. So that's going to give us a into negative 1 cube plus b into negative 1 squared minus negative 1 plus 2. We expect that to give us 0. Okay, negative 1 cube is negative 1. Multiplied to a, it's going to give us negative a. Negative 1 squared is positive 1. Multiplied to b gives us positive b. Negative negative plus 1 and then plus 2 is equal to 0. All right, so if we take it up here, we're going to obtain negative a plus b. Now we take all the constants to the right hand side. This is 1 plus 2, which is 3, positive 3, taking it to the right hand side, giving us negative 3. All right, so this is our second equation. We have our first equation and we have our second equations. Now we have two equations with two unknowns to solve. Okay, so this is solvable. All right, so let us now write them again close to each other. So we have here a, this 1 plus b is equal to negative 1. So we have two equations with two unknowns to solve. Okay, this is our equation 1. All right, now if we look at it, if we use the elimination method, for example, if we add the two equations, we're going to eliminate a and we're able to solve for b. So if we say equation 1 plus equation 2, we add a plus minus a is a minus a, so it disappears, it goes 0. And then b plus b, we're going to have 2b. Negative 1 plus negative 3 is going to give us negative 4. So from here, if we divide both sides by 2, we'll have b is equal to 2 here, 1, 2 there, 2. B will be equal to negative 2. So our value for b is negative 2. To get the value of a, all we need to do is to substitute this value of b in any of the two equations. So if we take, so if we do the substitution, b equals negative 2 in equation 1, for example, if we do that substitution, b equals negative 2 in equation 1. This is equation 1. So wherever we find b, we'll put negative 2. That's going to give us a minus b is equal to minus 1. All right, remember, what am I doing? This is a plus b is equal to minus 1. Now we're going to put b to be negative 2. That means a minus 2 is negative 1. We are solving for a, so we'll take this negative 2 to the right hand side. That means a is going to become negative 2 becomes positive 2. There was minus 1 already on the right hand side, so a becomes 1. Okay, So we have done the first part of the question, which says we should calculate the values of A and B. A is 1 and B is -2. So we have done the first part of the question. Now, second part says we should solve the equation f of x equals 0. All right. Now, that means that what? That means we have to write f of x now, putting the values of a and b. Okay. So the equation f of x equals 0 is writing all of this, putting the values of a and b and equating it to 0 and solving. So we have a was what? A was 1. So that means 1 into x squared. B is -2. -2x squared minus x plus 2 equals 0. 1 multiplied to anything is just 1. So we have x squared minus, cube, minus 2x squared minus x plus 2 equals 0. So this is the cubic expression that we have to solve, a polynomial of degree 3 that we have to solve. So as the rules of polynomials, a degree 3 polynomial will mean that we must obtain 3 solutions. All right? Now remember that we already have, that x squared minus 1, which we saw as x minus 1, x plus 1, was already a factor of this polynomial. The polynomial on the left hand side is a factor, all right, and which gave us already two factors from where we can get 2 solutions. So all we need to do is to find the last solution. How do we do that? We carry out Euclidean division. We can carry out Euclidean division, all right? Euclidean division with this factor that we know. Let us carry out Euclidean division of x cubed minus 2 x squared minus x plus 2. Okay, we'll carry out that Euclidean division. All right. Now, what are we going to write up here so that when we multiply back, we will at least eliminate this first term, right? Our aim is that when we do this subtraction, we should obtain a 0 for this first term here in this polynomial. So we should look for that expression that when we write here, remember we have to multiply back to have what we're going to write here. What are we going to write here therefore? So that when we multiply back, we are going to have x cubed at the beginning. If you look at it carefully, this is already x squared. So it will make sense if we multiply by x. If we write here x, so that x multiplied to x squared will give us x cubed. X multiplied to -1 will give us negative x. All right. So that when we do this subtraction, x cubed minus x cubed is 0. -2x squared. There is no x squared here. So what do? We can just write this as, since we have x cubed minus x, we can just write this as minus 0x squared minus x. All right? So that we have -2x squared minus, or plus 0x. -2x squared minus x squared will just give us -2x squared. All right? So that we now have negative x minus x. This negative x minus x. It becomes negative x plus x, which is 0. All right? So since that gives us 0, we are forced to bring down these 2. So we have plus 2. We have plus 2. All right? So we'll carry out the same process. What should we write up here? So that when we multiply back and we carry out subtraction, we must obtain 0 for the first term of this expression. What are we going to write up here? So that when we multiply with this, we are at least going to obtain -2x squared. It should be -2. It should be -2. So that -2 multiplied to x squared will give us 2x squared. Negative 2 multiplied to negative 1 will give us plus 2. So at the end of the day, what are we subtracting? Look at this subtraction. What are we subtracting? Something minus itself is 0. Something minus itself is 0. So our division process ends here. And so our quotient up there is linear. We expect it to be linear because our polynomial was of degree 3 and the dividend here was of degree 2. A degree 3 divided by a degree 2 must give us a linear expression. And this already happens to be the third and last factor for this cubic expression. And so we can write f of x equals 0 now as, instead of writing this, it is a product of this, that, and that. So we're going to write x minus 1 into x plus 1 into x minus 2 to give us 0. Okay? If you open out these brackets, we're going to have our cubic polynomial. So instead of writing it in this form and putting it to 0, we just write the factorized form of f of x. The factorized form of f of x is this product multiplied to that. So this is what we have, equals to 0. All right? So we have the product of three things giving us 0. That means either x minus 1 is 0. That means that x equals 1 is our first solution. All right? Or x plus 1 equals 0, which therefore means x equals negative 1 is our second solution, or x minus 2 equals 0, which also means that x equals 2 is our third solution. Okay? Therefore, solution for f of x equals 0 will be x equals 1, x equals negative 1, or x equals 2. These are the three solutions when this cubic, all right, when this cubic expression, after getting the values of a and b like we did, when this cubic expression is equated to 0 and solved, we'll have the three solutions: x equals to 1, x equals to negative 1, x equals to 2.